multi-channel orthogonal decomposition attention network for sequential recommendation. Presents a novel approach to sequential recommendation systems that utilizes features to make personalized recommendations. The paper begins by discussing the growing research in sequential recommendation and how early methods use the Markov assumption that current behavior is closely related to previous behavior. However, these methods are not always effective due to the lack of information about user preferences. To address this limitation, many researchers have attempted to leverage features to directly fuse various types of features into the item vector. However, this can be problematic because items and features are in different vector spaces, which can lead to a lack of consistency in the item vector space. Additionally, direct fusion of multiple features can cause mutual interference and make it difficult to capture feature transfer patterns. To overcome these challenges, the authors propose a new model called Multi-Channel Orthogonal Decomposition Attention Network, MODEN, for sequential recommendation. This model uses two different types of channels, one for items and one for features. The item channel focuses solely on pure dependency among items while the feature channel captures transfer patterns between them. The MODEN uses orthogonal decomposition and reverse orthogonal decomposition to extract each feature's contribution to the item, without interfering with the item vector space. Then, it fuses the contribution of different features into the item and ensures consistency in the item vector space. The authors also propose an attention approach for the feature channel that allows the model to focus on relevant features for recommendation. The authors evaluate MODEN's performance using two different datasets and compare its performance with other sequential recommendation models. The results show that MODEN outperforms existing models in terms of accuracy and efficiency. One significant advantage of MODEN is its ability to handle multiple types of features simultaneously while maintaining consistency in the item vector space. This is achieved through orthogonal decomposition, which separates each feature's contribution from others without interfering with their respective spaces. Another advantage is its attention mechanism, which allows the model to focus on relevant features for recommendation. This approach is particularly useful when dealing with large feature sets, where not all features are equally important. The authors also compare MODEN's performance with other sequential recommendation models, including FPMC and GRU4Rec+. The results show that MODEN outperforms these models in terms of accuracy and efficiency. This is likely due to its ability to handle multiple types of features simultaneously while maintaining consistency in the item vector space. One limitation of MODEN is that it requires a significant amount of data to train effectively. This is because it uses multiple channels and attention mechanisms, which can be. In this paper, we propose a multi-channel orthogonal conclusion, decomposition attention network, MODEN, for the sequential recommendation. First, we use multiple channels to process items and different features separately to avoid mutual interference in the vector space between features. Subsequently, we use orthogonal decomposition and reverse orthogonal decomposition to extract the contribution of the feature on the item, which avoids the interference of the feature on the item vector space. Finally, the contribution of different features on the item and the item representation is fused to ensure the consistency of the item vector space. Experimental results on 3 benchmark datasets show that our model outperforms all the other baselines.